Again, we are covering the subject thermodynamics for civil services mains, IFS, and various gate exams. The next topic in the chapter of entropy is first law and second law combined. So from the entropy relation, we derive that, or from the second law, we derive that dq reversible is equal to TdS. Okay. And from first law, for a non-flow or closed system is dq is equal to du plus pd. Okay, so we can put dq here as tds for reversible cycle. So it will be tds is equal to du plus pd. So this is equation number 1. Further, this uh, du can also be replaced. So h is equal to u plus pv. So dh is equal to du plus pdv plus vdp. And now this du plus pdv is your tds, or we can put du here. Okay. So du plus pdv is your tds, so it will be tds is equal to dh minus vdp. This is equation number 2, another form of combined first law and second law. So these are the thermodynamic equation relating the properties of the system. Here T is property, S is property, U is property, P is property, V is property, and H is property. So these by combining first law and second law, we are able to relate various properties. Okay, now we analyze various equations. So here first law, from the first law, the basic law, we have dq is equal to d plus dw. So this equation is valid for any process, reversible or irreversible, and for any system. So this is your basic first law. So now if we put d is equal to du, then this equation is valid for closed process, because d involves various kinds of energy, kinetic energy, potential energy. So we are neglecting these energy that is applicable to closed system and taking only the change in internal energy. So this is applicable to closed system. So this equation holds good for any process undergone by a closed stationary system. Okay. Now this dw is equal to pdv. We can put for a reversible cycle dw is equal to pdv. So now this equation holds good for closed system. du is for closed system and where only pdv work is present, and this is true for only for a reversible process, because this is for reversible, this is for reversible. Okay. So this is only true for reversible. If one term is there, then we can say this pdv or tds, then we can say that is for reversible process, because dw is equal to pdv for reversible process and dq is equal to tds is for reversible process. So that is valid for only reversible process. Okay. And closed system. Now dq is equal to tds, this equation is true only for reversible process, whether it is closed system or open system. Now if here if we put dq as tds, then tds will be equal to du plus pdv. Now it is valid for both reversible as well as irreversible, because these are the property relations. So T is property, S is property, U is property, P is property, V is property. So it is valid for any process, reversible or irreversible, undergone a closed system, because it is, since it is a relation among properties which are independent of part. Okay, so these are property relations. Similarly, TDS is equal to P is equal to DH minus VDP. This also relates only the properties of the closed system. So there is no path term like dq or dw. Okay. We have put the value of dq, that is TDS, and we have put the value of dw as pdv. Okay. So there is no path relation. Where we have defined the path. So no, there is only their property relation now. Okay. Hence the equation holds good for any process. So this is for any process, this is for any process, This is for reversible process only. This is for uh, reversible process and closed system, and this is for closed system, both reversible and irreversible, because we have not put the value of dw and dq. So this is for any system and any process.